these examples where we find the eigenvalues for this to find a solution x for this problem right here. Now you have to keep in mind this is also a system of differential equations. It's just that they wrote it in matrix forms already. So they did a step for us, which is kind of nice. And then they're giving us an initial condition. And I like to show you how to do this in Matlab as well, because we've already done this part. All we have to do then is plug in this to find C1 and C2. And so let's do that. Let's go over to Matlab and let's go to exercise 2. I'll get the other one out the way. And let's go to exercise 2. So here, I'm going to say this is exercise actually 13. And I'm going to clear all previous variables. And you do that by writing clear all. Then what I'm going to do is I'm going to define the matrix that I'm interested in. Again, it's a matrix. I'm going to use the square brackets. The first entry is 1/2, 0 for the first row. Second row is 1, negative 1/2. I don't want it to output, so I put a semicolon. And then I'm going to use the Jordan to find the eigenvalues and vectors. Remember, the Jordan outputs two things, vectors first and values second, so you need to give it a matrix output, and then we can just put Jordan and A. And once we get those outputs, we want to define another, well, let's just do that first. So we press Control Enter, and we get these two things, right? Now notice how these are eigenvalues, and these are eigenvectors. So I can say defining my general solution with the superposition principle, my general solution is going to be what? It's going to be the vector 1, 1 multiplied by the exponent of 1/2 times t. And plus, and I have to put a C1, which is a constant that multiplies. So another thing we want to do up here is define some variables, some constants. And so you do that with the command sims C1 and C2. I know I'm only going to have 2 in this case because I have a 2x2 matrix. And so then I'm going to write C2 multiplied by the vector 0 and negative 1/2, all multiplied by e to the, okay, I was looking at the wrong thing. This is actually a 1. So this is a 1, 1 right here. And then the exponent has that lambda, which in this case is 1/2 right here. And then here we have 0, 1, 0, 1. And the exponent here has the negative 1/2 times t. So I also need to define the variable t in here. So this is my general solution. Now let's say that this is a function of t. And I get that x of 0 is equal to 3 and 5. How can I put that into Matlab? Well, one way I could do that is I could say x of 0, that's going to evaluate this, has to be equal to the vector that they gave me, 3 and 5. Now I want to make sure that you guys understand what I'm doing here. So if I ask Matlab to evaluate x of 0, it's going to put 0 here, and it's going to evaluate this whole thing. Actually, let me do that for you real quick. before I do this. I'm just going to press Control Enter. It's going to execute all the commands so far. And then if I put x of 0 here, it's going to calculate. It's going to put 0 here, and e to the 0 is just going to be 1. So it's just going to have c1 here at the top. At the bottom, it's going to have 0. So that's going to be c1 times e to the 0, which is c1 times 1 here, plus c2 times 1 again. So this is what you get, right? So now if I use the solve command here, let me put that back in here. And I'm going to say that this line is solving for a particular solution. This is what's going to happen. Now, I don't know if this actually is going to work. We'll see. I want to use the solve function here. And I want to use this, and I want to say that I want to solve for C1 and C2 in here. And it's going to output two solutions. So again, I need to give it a matrix output, C1 sol and C2 sol. There's other things that you can put here, like real and true, but we're not necessarily saying, we don't necessarily want to constrain that. So we do that, and what do we get? Well, we get a solution for 3 and 2. So now I can take this and I can define my particular for the initial conditions given. So defining my particular solutions. Now instead of C1, I'm going to input C1 sol and C2 sol. And I'm going to press Control Enter again, and it should output here what my particular solution is. See, it just substituted 3 for C1 and 2 and 3 for C2. Now, there's another way to do it with the subs function, but this is what I was thinking at the moment. So this is how to solve for with initial conditions with Matlab. I hope this was helpful, and I'll see you next time.